Last time we started how can we start our project. Today we will start to model a real project, real floor to read the software. Be sure, what is the definition for this plan? Do you remember what is the meaning for this plan? This architecture. It will not be accepted. Does not make any sense to open this drawing and move it to reason. From this plan, I cannot understand what is your beam. I cannot understand what is the type of your slab. From this plan, I can understand where is the wall, where is the bedroom, where is the stairs, where is the bathroom, all of this stuff. So you need to convert this plan first to another plan which called structure plan or statistical system plan. This plan, I can read it and model it to reason. This plan can show you where is your column, where is your beam, and what is the type of your slab. If you can read all of this information from your plan called statistical system. So when you are working on capstone project, first step, you will receive this plan first. From the company, from the office, anywhere. Then, first step, you need to convert this plan to another plan, can tell you where is your column, where is your beam, where is your slab, what is the type of your slab. Sometimes you can use beam between columns, so each panel will have 4 beams. That means you are working on solid slab. Or your slab rested directly on a column. This time you can call your slab flat slab. Both of them work. One more information. Where can I lay out or where can I put my column? The best scenario to arrange your column, first to open your architectural plan. Does not make any sense to put your column at the intermediate area for bedroom or living room or your stairs. So I would like to watch my architectural design first when I'm looking for locations of columns. The best location for columns at corners. At each corner for your architectural design. If you have bedroom, if you have living room, if you have stair, if you have bathroom, the best location is your corner of your architectural design. Once you put your column, connect between each column by a beam. So beams, and each panel must be in between or within 4 beams to say this slab is called solid slab. Or forget your beam, that's it, just a column, just a slab, you are talking about flat slab. Just a reminder from last semester, anybody remember here, if your slab is solid slab, we have 2 types. Do you remember?
Two-way slab.
Yes, 2-way and 1-way. 2-way or 1-way, what is the area assigned to each beam if you decide to solve your plan manually? So if you would like to solve this plan with your hand calculation, you have to do this. Hey, we have column, we have beams at each corner. So you have shorter span, you have longer span. If you divide longer, divide shorter, and your value is smaller than or equal, I think, 1, you are talking about 2-way, I'm sorry, 2. Two-way slab, not 1. Two-way slab. If the longer and shorter, divided shorter, greater than 2, it's one-way slab. What is the difference? Two-way slab, you are coming at each corner and draw what? 45 degree, 45 degree, 45 degree, 45 degree to make this envelope, and you can say, hey, this area for this slab with finishing load, with dead load, with live load, with everything can be assigned to this beam. So if you would like to make analysis to this beam, you have to put uniform distributed load or trapezoidal distributed load equivalent to this area with everything on this area. If you have live load, if you have covering, if you have dead load, if you have everything on this area must be assigned to this beam. And each beam has assigned area. Sometimes it's triangle, sometimes it's trapezoidal. Do you remember that? If your slab is one-way slab, that means we have very long direction and very short direction, which called one-way slab. One way, that means the shorter span can be divided by 2. This area will be assigned to this beam, and this area will be assigned to this beam. Wow, if you are talking about only one panel, we need more calculations, we need more time. If you are talking about plan like this, so go ahead and do it for this panel. The same, the same, the same. We have different dimensions, so we have different calculation for each one. And also, remember, if you have beam like this, and you decided each panel is two-way slab, like this, two-way slab. Which beam I have to start with? I have to start with this beam. Why? I will say why. This beam has two areas, one from this side and another one from the other side. That's right. This beam called secondary beam. That means this beam not supported directly on a column. No. This beam is supported here at another beam or another beam. This beam supported here on another beam. So I have to solve this beam first. We have support here, we have support there, we have trapezoidal from this side. We have another trapezoidal from the other side, so you have to multiply this one by 2. Once you get and solve this beam, get your reaction R1, then go ahead and solve for this beam or this beam. Let's try. This beam supported here on a column, supported here on a column. We have triangle, we have another triangle, that's right? Mm-hmm. And at this location, we have concentrated load. This concentrated load equal this reaction R1. This is the reason why you need to solve this beam first, before solving this beam, because you need this reaction to be a concentrated load beside this triangle and this triangle. If you decided to get this reaction R, this reaction is a reaction on your column. If you would like to design your column, you have to solve this beam and this beam also, because you have another reaction from this beam on the same column. That's right. It's more complicated. If you are talking about only one panel or one beam or two beam, but if you have many beams in a very large area, wow, we need too much time to solve all of this beam. And if you have secondary beam and another secondary beam and another secondary beam, which beam I will start to get my reaction to the second beam and my reaction to the next beam? So the best scenario, we learn it, we understand how to solve very simple problem. But if you have very large problem like this, we need to use a software. You can draw your column, your beam, your slab, and the software can tell you everything. Can tell you what is the final reaction on your column, what is the final moment and shear on your beam, what is the final moment on your slab. You don't care about which area is assigned to this one or this one, which beam is supported by this beam or another beam. You got it? So right now we are going to start to define this plan on a software called RISA floor. The final or the main purpose for this modeling, we need to design slabs, we need to design beams, we need to design columns, and finally we would like to design foundation like footing. Okay? Your slab thickness, I assumed my slab thickness equal 5 inch. Excuse me, how can you define your slab thickness and you didn't design? Last time I told you we can predict your slab thickness. Yeah, if your slab is simply supported, you can define your thickness equal L divide 20. If you are talking about continuous from one side, your slab is continuous from one side, you are talking about L divide 24. If your both ends are continuous, you are talking about L divide 28. So I can predict the thickness of your slab. Your beams are 16 width and 30 inch. But I didn't design yet, but you can predict your cross section for beams. Do you remember how? Yeah, we have as the same table. If you go back to design of column, design of beam, I think your span divides 16 if your beam is simply supported. Do you remember? If your beam is continuous from one side, you have another thickness. I'm talking about H for your beam. If your beam is continuous from both sides, we have another value. If your beam is a cantilever beam, we have a different value. So I can predict before any design what is the cross-section dimension of beam. Your column, I have no idea how can I figure out the dimension of my column, so you can assume any dimension, like 20 times 20. But the minimum cross-section for column is 10 inch by 10 inch, or 8 inch by 8 inch, if you remember. Your loading, hey, this building is an office building. This building architecturally designed for office building. So your type of building is office. Anyone know why I need to decide what is the purpose of your building? For what? Life load. Yeah. For life load. Then I would like to get final bending moment on beam, shear, reaction on column, moment on slab. First step, like RISA, like we learned it before. First step, we need to figure out what are the coordinates of your point. So your origin, I will select this point as my origin. Floor, RISA floor is working on the X plane. Your origin and your axis are the X plane. So first point at 0, 0. Second point at what? 10, 0. 25, 0. 35, 0. 50, 0. 0, 15. 10, 15. 25, 15. 35, 15. 50, 15. This point. 25, 15. 10. I'm sorry. 0, 25, 10, 25, 25, 25, 35, 25, 50, 25, 0, and 45, 10, 45, 25, 45, 35, 45, 50, 45. What do you think? What do you think?
Lot.
Yeah, we have many. If you have a very large area, we have a many, but we have another option. You can move your drawing from AutoCAD to Reza. If you have your drawing on AutoCAD, you can move it from AutoCAD to Reza directly. But we need to start first with the basics. How to use Reza to define, then the advanced option. Anyway, so here is your origin. We have Z, we have X axis, so you can define what are the coordinates of each joint. Any question? Any question so far? Okay, let's start and see. There is a difference between Reza 2D and Reza floor or not. Let's see.
You don't have reason.
Here is Reza floor, FL. Open it.
We don't have it.
The same music, that's
We don't. We don't.
okay. Here you go. We need to create a new model. We need, no, look to me. Don't write anything. Everything is written in your notes. So just look to me. So we need to create new model. So click this icon. And what is the name of your plan? You can define. Maybe we have many floors in one building, but each floor is different. We have one floor for solid slab, another floor for flat slab. So you can name or label your floor. Anyway, are you working on concrete floor slab? Yes, we are working on concrete floor slab. What is the elevation? What is the height of each floor? What is the typical height for each